So thank you very much. My name is David Murray. I'm a systems engineer with Arista Networks. For those of you familiar with us, you probably know us for our range of Ethernet switching platforms specialized in the data center. But today, I'd like to talk more about advanced network monitoring. So just to set the scene for what I'd like to talk about, where we've come from and how those tools have developed, which is really data centers don't look a lot like this anymore, right? If we think of the earlier days of building data center networks, they were much simpler than they are today. So, gone are these days of isolated tower servers where our applications are extremely isolated. So, you have typically one operating system, often one application per device, and the actual traffic patterns we would see on the network, because of that, were a lot simpler, right? Typically, applications and workloads were static, so we knew exactly where a particular application was living. And the network protocols, the types of traffic we would see on the network, were also much simpler, right? We might only be seeing a limited set of protocols like HTTP, SMTP, and so on, and we knew where they were coming from. So from that point of view, it's much simpler to monitor, much simpler to troubleshoot and debug. Let's look at how network and data center infrastructures have evolved over the years. There's just an awful lot more complexity in pretty much every direction. So not only have the number of applications, the bandwidth demands, the types of traffic of those applications increased and varied, but also we have this dynamism of our workloads, right? Virtualization has meant that compute and application workloads can be anywhere on our network. So we need that ability to troubleshoot and monitor wherever they are. At the same time, in certain environments, there's increased regulation for recording traffic information and so on. That's meant it's a lot more difficult to monitor these networks in the traditional manner. To illustrate this example, we have here a systems administrator calling the network team, and this is one of the most awful questions you can hear, is the network is slow. Well, not only the network is slow, but the network was slow several hours ago. How do you fix a problem like that? And often, unfortunately, for many network teams, the answer is a very unfortunate one of, let me plug in a sniffer and let me know if it happens again. That's not a great response. That's not where we want to be. It's almost akin to the IT support answer of, have you tried turning it off and on again, right? So yeah, you can maybe look at some SNMP stats or something like that, but it's a very difficult problem to solve. So really, this is what we don't want to be doing as our first port of call in terms of troubleshooting and monitoring, which is an extremely fine-grained analysis of the packets on the wire, right? Like, yes, this has its place, and this can be very useful, but in a typical situation, it's not where we need to start, right? We need to start at much a wider network-centric view, and then only if necessary, deep down dive into those packets on the wire. Where we actually want to be is have a very holistic network-wide view of the state of the network, so we can be more proactive, but also such that we can actually find the source of the problem across the network. Right? It's very good to be able to have packets on the wire if we know where to look, but often the problem is we don't know where to look in the first place. So that's essentially where we could be here, right? Where it's either plugging in a sniffer or a network engineer essentially walking around the DC with his laptop. Now, I'm sure most of you are a little more advanced than this, but I think it does illustrate the starting point. So I would imagine most of you in your environments have evolved to something that looks a little like this, right? We can actually get network-wide data analysis through stats, so SNMP-based polling and so on, but also through flow data, where we can do a very coarse network-wide level view of the traffic flowing in the network. And this flow data can be very useful, especially in certain environments. right? If I'm a service provider, flow data can be extremely useful in looking at the distribution of my outbound traffic, for example. But what it doesn't tell you is often the very specific kinds of problems where you need to look for a specific type of traffic, or you need to record a specific type of traffic where sampling will not cut it. But then again, this yellow line here, you can see, is the associated cost. And the associated cost with installing a flow-based collector, an S-flow collector, let's say, and enabling it on all your network devices is actually quite a big win, right? Because it's extremely low cost, but we can achieve a lot more visibility. But really, I think where we need to get to is something that looks like a lot more like this, which is truly a full out-of-bound monitoring network. What this allows us to do is have a full, rich network-wide visibility into the network. I don't think many of you will be doing this today, and perhaps the reason you're not doing it today is this hockey stick graph of the associated cost you can see, where really the costs really ramp up when you try to get a full out-of-band network, because often you're duplicating that network, right? Not only are you duplicating the amount of bandwidth needed in the original network, but also the costs associated with these types of monitoring networks can be prohibitive, and I'll talk about that. But really, when I talk about an out-of-band monitoring network, I and Arista, we prefer to use the term tap aggregation. And this is really where we're taking a number of easy-to-reach sources from the network, so monitor ports and also passive fiber taps, and aggregating them into a single point that we can then manipulate, consolidate, filter as necessary to be able to offer that traffic to a wide range of network tools. You may have also heard these devices known as matrix switches, packet brokers, aggregation devices, and so on. So this is really what we're wanting to get to, but unfortunately, there are, in the traditional solutions, a wide range of stumbling blocks here. The first is often these solutions are proprietary, which often means they're offered at proprietary price points. We have this somewhat perverse situation where the price point for your monitoring network can be an order of magnitude higher than the price point you pay for ports on your production network. So your monitoring costs can be, extremely astronomical if using the traditional approach. Not only and as part of those costs, we can also have a rich, complex set of feature licensing, where the features, the licensing can be per feature and also per port. Not only that, but with a proprietary stack, you will then have a distinct set of skills to learn, and likewise, that set of skills will be relatively limited on the wider job market for both hiring and transferable skills. So they're probably the reasons why the power that these aggregation networks can give you are not widely deployed today. This is where we want to be. And where we want to be is really not only being able to answer those questions for the server team, but be proactive. So rather than being on the defensive all the time, we're actually playing offense. And we can actually call the systems team up and say, hi, we noticed, you might have noticed some network performance issues because we saw you were having some trouble with vMotion. Right? It looks like at 9:12 in the morning, someone tried a major migration across pods. So that's really the point we want to get to, and having this wide set of monitoring and visibility can help you achieve that. So how do we get to this point? I've already talked about the problems of extreme cost and proprietary solutions. And this is hinting at where we want to get to, really, which is firstly, we need to be able to commoditize this product, right? It's just not practical to be paying extremely prohibitive proprietary pricing for when you're used to paying commodity pricing for much of your routing and switching. Likewise with that, simplify the licensing approach, minimize that operational overhead by perhaps allowing you to manage these devices as you would a normal network device. And what that means is not only having the familiar command line syntax and so on, but also a wide set of APIs on top for powerful automation and orchestration. So, as you may have guessed, the Arista way to tap aggregation looks a lot like our Ethernet switching portfolio. That's because it is. So what we're doing is we're taking that regular merchant custom silicon and applying that to a use case that allows us to use the device in this monitoring platform mode. So what that does is it gives us that powerful set of cloud scale economics where we're taking that merchant custom silicon, and it means the price per port you will be paying is identical to the price per port you were paying for your production network. So straight out of the bat, we can have a full range of interface speeds up to 100 gigabit at those Ethernet switching price points. But not only that, there's a wide set of features we can actually do on the box using that custom silicon. So to use some examples, we have hardware timestamping. So using a precision oscillator on the device, we can apply an extremely accurate timestamp to each packet in wire speed. We can do a wide range of traffic filtering, slicing, truncation, load balancing, and so on. That means we can offer packets to monitoring tools in already a quite specific way. Not only that, it's the wide set of APIs and the familiar command line syntax. That means you can manage these devices as you manage your production devices. And really, it is a fully featured data center switch. So what that allows you to do is repurpose your devices. As your speed demand increases, you could repurpose these devices into a production part of your network. So there's a wide flexibility there in having the same hardware, not only the same hardware, but the same version as well. So the same binary software image. But talking about tap aggregation, I don't want you to think of this in isolation. Really, it's a wide set of visibility and monitoring features we can achieve across the network to allow you to pinpoint those problems in a very precise and easy way. To use one example of that, we have a feature on every single one of our devices we call Advanced Event Monitor. And what Event Monitor does is take every time there's a table change on the switch, every time we run an ARP, a MAC, a routing entry, we actually write that change on the device to a local SQLite database. What that gives you is almost a historical view of the routing table, a historical view of the MAC table, right? A common network question is not what the tables look like right now, but what the tables looked like when you had the outage, right? What changed before and after a network event to cause some tool? And this can be very powerful in troubleshooting, right? I can run these commands of, what did the routing table look like last week? And what this gives you, in combination with these monitoring platforms, is that really rich stack of visibility. This is where we are today, which is you're having a very cost-effective aggregation platform in connection to the existing rich visibility on the devices. So starting off with this combination of on-device monitoring and S-Flow, we can then add on top of that this aggregation platform to allow us to selectively monitor data as and when required. And if we want to go really full, we can build a full out-of-band network such that any point, anywhere in the network, we can deterministically and very simply selectively monitor traffic. And this can be also in an automated fashion. Talking about that rich integrated stack, we can actually use the wide set of APIs and programmability on the devices in combination with the tools to actually selectively monitor traffic in an automated fashion. You can write rules such that if you see a network event, such as a vMotion, you can automatically start recording monitoring data, for example. So what are the use cases here? The big one big ones for us that we see are across a wide range of industry sectors. So yes, there are certain regulatory requirements, for example, in government and finance, but it's not just limited to those use cases. Service providers, for example, Web 2.0 cloud, data center businesses, we find that these platforms are extremely useful in able to capture, record, and troubleshoot a network problem much more quickly. So, for example, performance issues, regulatory reasons, compliance, capacity planning, lawful intercept, recording of traffic, security, threat mitigation, all of these use cases can benefit from a much richer visibility platform. So to summarize this solution, really, we're introducing that commodity economics of using regular merchant silicon, non-proprietary systems in your out-of-band monitoring network as well as your production network. So consistency of hardware, consistency of port speeds, port pricing, consistency of software versioning, and configuration and automation. With that, you get the much simpler licensing system that you're familiar with on a switch compared to one of these proprietary stacks. And really, you're making the most of this hardware. You've got that ability to replace and move devices around in your network based on the needs and the demands and port speeds and so on. So I do work for a hardware vendor ultimately, so I have to have one speed on hardware, which is our set of platforms that support this feature set. So at the top, we have our 7150 series of 10 and 40 gigabit switching. What's quite interesting about these devices is they actually have, I believe, the industry's only quad-speed port that can do not only 100 meg and 1 gig and 10 gig, but we can actually do 40 gigabits in the same interface as well by bundling 4 SFP interfaces into one native 40 gig interface. So there's a wide set of flexibility and speed changes all in a one IE box. For more power, we also have our range of 7280 platforms that today do 100 gigabit in one IU. So an interesting use case here would be taking 10 gigabit and 40 gigabit network feeds from your network and be able to offer that into a 100 gigabit port. So if you need to capture large volumes of traffic, this can be a very cost-effective solution in one rack unit. If you need more ports above that, we can give you up to 1,152 10 gig ports in a 11 RU chassis. So wide, very scalable range of hardware there for these sorts of needs, and they're also repositionable in your network. In particular, the 7500 chassis here can actually be operated in a hybrid mode, where one or more of the line cards can operate in tap aggregation mode, performing this network aggregation and traffic manipulation function, while the rest of the switches stay in forwarding mode. So you can actually, there's no new devices in this network to be able to achieve this quite powerful function. So I hope that was useful. Thank you for listening. Any questions?